So what would happen, like if you look back to your green exploration, that first graph that on the front, the cubic that just crossed the x-axis one time, it had one real zero and it had two imaginary zeros. For the one that maybe you said it looked like, some people said it had two x-intercepts, it really had three x-intercepts, one with a multiplicity of two. So then it counted as the third zero. And then the last one did actually cross three times. So actually every polynomial has the same number of zeros as its degree. So from here on out, when I ask you about zeros of a polynomial, you know that like the answers you write on the line should match the degree of your polynomial. And if you have n zeros, we could put all of the zeros back as factors. So we would have how many linear factors? N linear factors. Okay. If we say, if we say that your 0 was at like some value k, then your factor for that 0 must have been an x minus k. So you just put them back with the minus sign in front of them, and then you have your linear factor. Now, some of those factors, like think back to the blue exploration, we had that letter C where we had 1 plus or minus the square root of 3. So sometimes your linear factors have irrational numbers, and then sometimes your linear factors, now we know, of course, might have complex or imaginary numbers in them. So another little quick fact that you should know going forward. Complex zeros, so the zeros that are imaginary, they always come in pairs. If a plus b is a 0, then a plus bi is a 0, then a minus bi is also a 0. Never will you see one without the other. If you do, you know the other one is there. It should make sense to you that they would come in pairs, because how do you even get I? You square root negative numbers. But if we're solving and square rooting, don't we always add a plus or minus when we square root? So in the quadratic formula, there's a plus or minus the square root. If we're solving by reverse PEMDAS and we square root, we add the plus or minus. So we're always going to get a plus or minus bi as a set of zeros. And I never wrote this down officially. I did mention it when we looked at the blue exploration. But the same is true for your irrational zeros. Like they come in conjugate pairs. A plus or minus the square root of b. So like that letter C on the blue sheet, 1 plus or minus the square root of 3. If you have 5 plus the square root of 7 as a 0, then you know 5 minus the square root of 7 is also a 0. They'll always come in pairs. Okay, so here's what your 2 homework problems are going to look like. Okay. I'm going to ask you to write a polynomial for the zeros that I give you. So today you start with the zeros and you write out the polynomial. On Monday, we're going to work backwards. I'm going to give you a polynomial, and we're going to do all that work to find the zeros. And on Tuesday, we'll put those things all together on a graph. So write a polynomial function that has real coefficients and the following zeros: 0 and 2 plus I. How many zeros have I told you about? 2. How many zeros must this polynomial have? 3. If 2 plus I is a 0, we know 2 minus I is also a 0. Never will 2 plus I be all alone. His conjugate will be there. 2 minus I is also a 0. So in the end, if you have 3 zeros, you're going to get what type of polynomial function? Cubic, third degree, right? So if we want to write the polynomial, we're going to start with, I'm going to write this down, the linear factorization, which that's just a big word for factors. So I just need to take all three zeros and write a linear factor for each one, x minus k. The first one is x minus 0, so I can just write x. The next one, I want to do x minus the complex number 2 plus I, so I'm going to go ahead and protect that with a set of parentheses, because I'm subtracting that whole number, right? 2 plus I. And then I'll have another one that looks like x minus 2 minus I. So this is a very similar setup to what we did on the blue exploration with the irrational zeros. So that's my complete factorization. That's my linear factorization. If it's a cubic polynomial, I ought to have 3 factors listed. Okay, now I want you on your homework to actually work through and get your answers. So what I would probably do is distribute this negative to your complex zeros. So it's going to be minus 2 minus I and minus 2 plus I. As long as you have the conjugates for the complex zeros, when you FOIL those out or distribute, you will get rid of i's. So the direction said to write the polynomial of the real coefficients. The i's will cancel themselves out. Okay. So this would be like what we did on that blue exploration. I would just FOIL a trinomial or distribute a trinomial times another trinomial. So I'm going to have 9 terms. But I know I should cancel. X times x is x squared. X times negative 2 is negative 2x. And x times I, I'm going to call it ix. Then I'm going to distribute the negative 2. Negative 2 times x is another negative 2x, so I can stack it under the x term because they're like terms. Negative 2 times negative 2 is a plus 4, and I don't have a number yet, so I'm going to put that over there. And then negative 2 times I will give me a negative 2i. Now I do have an I in this term here, ix, but 2i doesn't have an x. So those are not like terms. I'm going to go ahead and make my minus 2i another column. They won't cancel each other out. You can't add an ix and a 2i together. And then I'll do the last part, which is my negative I. So negative I times x just canceled out my ix, right? That's good. Negative I times a negative 2 is a plus 2i. I just canceled out my 2i's. Also good. And then the last one, you just have to be careful here. I got negative I times a positive I. So that's a minus I squared, which we know I squared is really a real number, negative 1 minus negative 1. This is really plus 1. So then that trinomial is x times x squared minus 4x, and I'm adding the plus 4 and the plus 1 right here, so plus 5. If you always choose complex conjugates, the i's will always cancel, and you'll get some quadratic with real number coefficients. Okay. You know, think about this. This does not factor. You have no factors of 5 that could add to make negative 4. 5 and 1 will add to make 6 or negative 6. So that doesn't factor. You'd have to quadratic formula. If you quadratic formula, then you get the 2 results, 2 plus or minus I. And then finally, of course, distribute x cubed minus 4x squared plus 5x. Questions, concerns? Now, I showed you, back on the blue exploration, I showed you, a shortcut for distributing if you don't want to do trinomial by trinomial. That shortcut would hold true. if you wanted to give that a go. So if you've been using that for the irrational zeros, you can continue to use that for the imaginary zeros. But if you've been doing like the 3 terms times the other 3 terms, I would just keep with that. You'll get the right answer. Okay, so what I want you to do before we get the quiz out is have a quick discussion with your groups about end behavior for this polynomial. If I give that to you on the quiz, can you tell me the end behavior in mathematical notation for the polynomial on the board and tell me why it is that way?
That's oh, you can have that. You can have oh, this isn't like that. You can have this too. Oh, just realized that's your pencils. I realized.
Okay, so end behavior, you're using what we call the leading coefficient test. To start the leading coefficient test, you look at the leading coefficient. Okay, so the leading coefficient is in front of the term with the highest exponent. That would be a 1 right here. You're asking yourself, is the leading coefficient positive or negative? And it will tell us about which side of the graph. The right side. The leading coefficient will only tell you about the right side. Okay. So if the leading coefficient is positive, the right side rises. If the leading coefficient is negative, the right side falls. Okay. So we want to write this in mathematical notation. How do you say right?
X.
As x approaches positive infinity. Think about your x and your y-axis. As x approaches positive infinity, you're going to the right. What is your y doing? Approaching positive infinity. We've got positive leading coefficient, so it's going up. I got a right arm going up. Okay. In the leading coefficient test, what do you look at to determine the left end behaviors? The degree. Now, how do we change our question? Instead of positive or negative, we ask even, odd. So for the left side, as x approaches negative infinity, we have an odd degree, so our end behavior should do the opposite, a negative infinity. We're comparing it to the other y. So you can have, like, these things will always be the same, right and left. Over here, you can answer positive, positive, negative, negative. Those would be even degrees. Or you can have positive, negative, negative, positive. Those would be odd degrees. Okay, how will you decide which one? You'd look at your leading coefficient, and that'll tell you the first one. Okay. All right. So go ahead and clear your desks, pen or pencil.